What, guys?
Always.
So we must always break this diagram into three parts. The first part, the second part, and the third part. So firstly, we must know what we are going to find. We want to find the moment of inertia about the centroid y-axis. So there are some of the keywords that I would like to highlight here. The first one is part. In this diagram, I break it into three parts, so we must know which part are we analyzing. The second is IY, which is the moment of inertia based on the shape. This you can refer in the diagram in the table. So we are breaking the diagram into three rectangular parts. The first part, the second part, and the third part. And its moment of inertia is equals to B cubed times H divided by 12. B is the width and H is the height. So next we have to calculate the area of the part, which is A, and D will represent the distance between the given y-axis and the y-axis of the centroid for the part. And finally, we must know the product of AD square, which is the product of the area and the square of D. So next is we have to construct a table based on the 5 keywords mentioned above, which is part, IY, A, D, and AD square plus IY. Actually this one is AD square plus IY, which is the moment of the respective part. So we compute it. For here, this is part 1. The B for part 1 is 15 times 50 plus 50 is 100. So 15 cubed times 100 divided by 12, you will get 28125. And for the area, you calculate for the area for this part, which is 15 times 100, as you can see right here, and you will get 1500. And the distance is the distance between the given y-axis and the y-axis of the centroid. So to find the distance we can calculate from the origin towards the center. We assume that here is the center for this point, so we must find the area, the distance between here to here, which is here is 15. So 15 divided by 2, and then you minus with 100, because 100 is the distance from here to here, and you will get the distance from here to here, which is 92.5. And finally, we must calculate the AD square plus IY, which is 1500 times 92.5 square plus 28125, and you will get 1286.2500. So the same step applies to the next two parts, which is part 2, this part 2, and part 3, which is this part. For part 2, which is the middle part, is the D is equals to 0, because the centroid is located at the center, which is also the origin of the given axis. So the axis is 0. So after you have calculated all of this element right here, for this you will get 4094166.7. and this one you will get 12862500. After you have calculated all of the element here, you must make its summation. The summation of AD squared plus IY, which is you plus all of the calculated values, and finally you will get 29819166.7. To simplify it, we write 29.8 times 10 to the power of 6 millimeter to the power of 4. So this is the moment of inertia along this about the centroidal y-axis. So I think that is all from me. Thank you.
Okay, bye bye, ther.